actually started discussing the different elements of your syllabus, but now from this week onwards, we'll get into the different components, different processes. If we talk about multi-processing, multi-programming, and multi-threading kind of situation. So from this week onwards, we will start touching upon the different multi-tasking or tasking kind of processing in a such system, right? Because from the very first day we are saying there are two views of a such system. One is as a process, one is as a system. Such system, such process. That is one broad view you should always have. And second, when we talk about designing a such system, it is naturally we are talking about different sub processes, different computing blocks within the such system, right? So when we talk about the components of a search system, it typically means it could be talking about indexing, it could be talking about ranking mechanism, it could be talking about matching part, how matching between query and the document terms will be performed in the different settings, right? So there are, I can say there are 6 or 7 main computing blocks within a search system. And from this week onwards, we will start talking about these different elements, processing elements into the search system, right? So today we'll talk about the related concept, which we have discussed in the previous week, and particularly one thing which is most important to discuss before we start actually talking about different elements of a search system, right? So like in the previous weeks, we have talked about different factors like how overall such systems are being designed in the years, and how basically retrieval process is planned according to these different assumptions on overall actually. But today we will discuss one important factor which is again related to the fundamental concepts of search system or search engines, whatever you say, and it is called the frameworks, right? Metamorphic frameworks. So when I say this term framework, it is having two elements into it. First is called metamorphic. What is metamorphic thing you need to see, and what is framework? So when I say framework, because in computer science we used to have different terminologies, right? And we often get confused by the terminology itself, that what this terminology is referring to, right? So sometimes we say it is a strategy, sometimes it is a technique, sometimes it's a algorithm, approach. There are many terms which we use in basically the formal discussions about a technology or maybe something related to the IT kind of solution, right? So when we say whenever we say framework, you should have this clarity now. Whenever we say framework, it is talking about, it is basically outlining the boundary of the system, boundary of your solution, right? So when I say framework, it means it is talking about end-to-end solution. End-to-end means after that there could be another system. After that it could be user. After that it could be a second processing element. That's it. So whenever we say we are proposing a framework, like you are now started exploring literatures related to your project works. So whenever you say in your project work or in any dissertation work framework, it typically means you are proposing a entire solution. End-to-end solution I'm saying, right? So if you are designing a framework for search process or search system, it means you are designing all these internal elements of a search process or system as a new phenomena, as a new altogether novel kind of thing, right? Each and everything within that framework will be new, right? And when you talk about component, one of the component you're revising, it is not a framework. It could be an approach. It could be a matching strategy. It could be a technique to create indexes, something like that, right? So framework is basically, so whenever we refer framework, it refers to designing altogether new solution, new product, basically. I mean, if you relate with software engineering concepts, whenever we talk about framework, it is basically about creating entirely new product, right? So it could be a search system, it could be a recommender system, it could be a question answer based system, it could be a social search system, it could be a cross language information retrieval system. So there are many retrieval systems we will be talking. Now, what about this metamorphic? You know, as a computer science student, we are having different algorithms, right? So whenever whenever we face some question, whenever we face some, situation to deal with, we basically tries to formalize a solution, right? So naturally, whenever we tries to formalize a solution, we take some inspiration either from real world or from some existing equivalent behaviors in the real world. I'm seeing, right? So whatever pseudocode we write, so pseudocode is one of the example where you can say this is a metamorphic representation of a solution. Like in the previous semester, you might have gone through a course called, or maybe in this semester, you are revising a course called optimization techniques, right? In that, when you read GA, genetic algorithm, right? So when you read or when you experience about genetic algorithm, it is nothing but it is a metamorphic, that GA algorithm I'm talking about. Genetic algorithm simply a metamorphic representation of the evolution process, right? Which happens in the living species. It could be human, it could be anyone who is having DNA structure, right? So two operations of this genetic evaluation has been, not evaluation, genetic evolution has been mapped into a genetic algorithm. So initially it will start with two chromosomes or two input DNA structures, and in between we have two operators. It could be crossover, it could be a mutation, it could be selection, probably three operators, which helps you to get new set of operands, new set of DNAs, new set of structures, new set of offsprings, probably you can say, right? And that is how basically evolutions are happening in the living species. So basically this genetic algorithm, which is a pseudocode again, it depicts, I'm using this term depict, it depicts the existing phenomena which is already happening in the world. There are many algorithms, optimization algorithms, which are there, which are existing in the nature. Like you must have read about ant colony optimization, ABC. You must have seen this, bee behavior, bee optimization technique. There are almost, if you take alphabet A to Z, for each alphabet there is an algorithm, there is an optimization algorithm. A is for ant colony, B for bee optimization, C for something like that. So if you take A to Z, there are n number of situation existing in the world for which we have converted, for which we have created an algorithm. And now we are taking, we are observing, we are adapting these algorithms to solve some new situation, some new problem we are facing. I mean, in the last year, I was going through one of the algorithm, which is related to, I mean, they are having a new optimization algorithm based on the behavior of student learning. Like in the classroom, there are suppose 20 students. There are two levels of learning involved. One is through teacher and another through among the student groups, among the students. And it is called TLBO, teacher learning based optimization. So you have modeled that phenomena, and after modeling, you have created a metamorphic representation. Meta means, again, something written in the intermediate representation. So entire concept, entire phenomena is now your behavior. Behavior in a situation is now modeled into a form of pseudocode, maybe in form of some algorithm directly, or maybe in form of any tool. So whenever we see these metamorphic frameworks, it helps you to design the system, it helps you to enhance the system, and sometimes it enhances to break into a new, altogether new situation, altogether new novel system design. Right? And why we are discussing these metamorphic framework in that detail. So if you read, there are two frameworks available. And if you believe in the world, when I say, it means in the world of IT, the search engine search system, and in the real life where we are actually existing, there are two base frameworks, two base behaviors which are being utilized to design any kind of a system. So we have like in the case of optimization, we have n number of algorithms for which we have created metamorphic frameworks, and then now we are using these different algorithms to solve different optimization situations. Similarly, from the very first day, from the very first generation, whatever search system, whatever retrieval systems we have designed, these retrieval systems, search systems, are based on these two behaviors, these two metamorphic frameworks. One is called berry picking, and now this could be the question for this classroom. Out of this classroom, that is, what is the difference between berry picking and food foraging behavior? So there are two behaviors which are observed, not today, not previous year, not 5 years back. It was during early 80s when this need of search system, need of this retrieval system has been observed. So during those days only, these two frameworks has been observed as a fundamental framework to design the search system, to design a search process. Now, why we are having emphasis on these two behaviors? Because these two behaviors are the behaviors which exist in the world. Now, all the optimization techniques which we have observed during first semester or maybe this semester are primarily based on food search, food foraging, actually, looking for the food source, looking for the food for the survival, for the existence. That is the dominant one, and based on that only most of the optimization techniques, optimization algorithms are based on. Right? There is a specific behavior which we have observed as a fundamental framework, which is coming from or based on berry picking. And then berry picking, nothing but it is just like picking the leaves, like in the tea garden. Like if you go to north part of the world or northeast part of the India, they are just picking up some leaves from the bushes, tea garden. So it is like the same thing. So out of entire farm area, you are naturally looking for a particular bush area from which you can take out the most suitable, most appropriate, most correct leaf that can be reproduced as a tea plant, right? So it is equivalent to the same behavior. You are going to a bush area naturally, and out of this entire bush, different bushes, you are going to take one particular bush and you can take out the berry, which could be, in good taste probably, right? So it is a first behavior which has been observed that can be taken as a fundamental behavior to design the search system, right? And second behavior, which is largely utilized in modern day systems, it is based on food foraging. And for this, you can take anything, right? So we'll see partially about these two. So why these two fundamentals are being used. So you can take out few questions related to this and search and look for the answer, like how these two behaviors are similar, how these two behaviors are dissimilar, what is the internals of these behaviors, something like that, right? So the emphasis on these two behaviors are different. In the berry picking based behavior, so if you observe berry picking behavior in the real life, their focus is to identify the specific or maybe very relevant or related details from a source. So if you consider that bush area or maybe bush part, that could be your information source. It could be a PDF file. It could be a web document or web page, something like that. But our objective is to match or to spot on a particular portion, particular keyword within the document, within the bush. So berry picking behaviors are reflecting the need of the importance of focused information search. So anywhere or in any system which require this nature, focused information search, narrowing to a more specific part, that could be based on berry picking. You can design a search system based on berry picking behavior where narrowing down to detail is the mandatory thing or the most essential thing, right? So it is kind of looking for a local optima. Naturally, you start with many bushes, many options, many documents, many search results, but eventually you will be, looking or making your search narrow towards few results, and then eventually goes down to one specific, something like that. And this behavior you can correlate. It is happening in many platforms. Like if you take e-retail platforms, there also you start with searching many products. Then you goes down to one particular product. Then within one product category, then you narrow down to one certain particular product and purchase it. That's it. That's what, right? This depicts the basic berry picking behavior in the search recommender system in many platforms where search is essentially available. So berry picking based systems are primarily based on, or they depicts or they outline the importance of focused information search. Now we have observed after a few years, we have observed there is a need of a new element. There is a need of new aspect which could be added into the search system. Or maybe you can say there is need of new type of search systems, which emphasizes the importance of exploring all the possible information sources. In the first, what we have said, we have said we have to focus upon the specific details. You can start by having many results, but eventually you have to narrow it down. That's what the search should be. But after a few years, it has been realized that a search system should also emphasize on the capacity of reading to all the sources, reading to all the PDFs, all the search results. Can we provide some mechanism through which user can read it, user can explore all the possible information sources, all the possible food sources, something like that. And then if he is interested, he can narrow it down, extract, read one of the possible alternatives. So importance of exploration, browsing is realized by using food foraging behaviors, food foraging based scenarios in the search system. And nowadays, if you see any recommender system, they are providing these filters, features, price, quality, star ratings, and all those things in the left side. And they are primarily there to provide you some sort of control to explore, to browse each and every food source. You can control the list of food sources, list of products, list of results directly by using these features, these aspects. And if you are interested to get inside of a product, inside of a document, inside of a result, you can directly go down. That's it. So it is having basically, and that's why we are having these kind of good information systems nowadays. Maybe in the form of recommender, maybe in the form of any website. They provide a kind of balance between two behaviors, berry picking behavior and food foraging. So basically, berry picking provides you the capability to basically focus on a specific detail within a source, and food foraging basically provides the capability to control or the browsing part. You can read at least once, you can have a glance at least once on all the food sources, all the results. And if then in the second phase, second step, if you are interested to read one, you can go or you can narrow it down up to your interest, right? So based on these two behaviors only, we can say most of the search systems which are available for public domain use, search engine, search system, retrieval process, anything you say, they are just balancing these two behaviors. One is berry picking and another is foraging, right? And closely related to these two behaviors, we can say we are basically talking about two important behaviors, two important phenomena. One is called exploitation, another is called exploration. And this is the philosophy of any system design where user presence is required, where user presence is observed, right? So system design for user is primarily talking about or highlighting the importance or need of balancing these two factors, exploitation and exploration. So exploitation means, so if I am talking about balancing these two factors, it means it is primarily talking about you should have some focus on the extraction of detail in the bottom level details, bottom level computing, and you should have some control over, through which you can explore or read at least all the sources. That is called exploration, right? So each and every system design where user is available, user is existing, you should balance these two factors, right? So that's what the broad philosophy, and these two philosophies are coming out of these two broadly underlined real life behaviors or frameworks, that rather you can say, right? So in the previous class, we have touched upon these inside view of search process, and we have discussed that there are different phases of a search for which we have some notions, some concepts we have already discussed, like how to model the search relevance, how to model the user query, how information need is reflected into query and query is getting you the result, how after reading each result, your CW part is evolving, right? So basically, we will talk about these three factors in upcoming classes, where we are talking about the different elements like past search experience, how current knowledge gain is playing a role, and how these three cognitive processes or cognitive activities like remembering, thinking, and visualizing have a role on the search system design, right? But as of now, we are talking about the two main aspect, which is called balancing, exploration, and exploitation in the search system design, right? And because based on these two only, each and every search system, I'm saying search system or search engine is designed, right? So basically, that's what we have already iterated, that exploitation behavior or exploitation factor is emphasizing on the focused search within a information source, right? Now exploration is it is emphasizing, it is placing importance on the browsing of information sources, browsing of all the relevant information sources, whatever sources are existing for your needs, it will be browsed at least. So for that, you need to provide something on the search system, right? Now after this, if you see the typical search process, right? So this diagram typically shows you the basically one point of view on the search process, right? So like any search process, start with giving you the first query into the search system. And this is again a revision of whatever we have discussed in the last week. Now, we start with Q0, which is the first query, right? Now, after submitting this query, you will get some set of results, right? Like here we have. So this could be document, this could be anything, which is system is generating to you for your query. Now, after this query, you will have some result. Now, after this, after reading to these results, after getting some details out of this result set, your query will be now revised. That's what we have said in the previous discussion, and it will become Q1 basically, right? Now Q1 is here. Now each and every curve you can see. So it is a continuous process. You go to Q1, then you will get result to R1 basically. Then this goes to Q2, which is query 2. Then you have you could have a query 2 and directly Q3 without having any exposure to the results. It is possible. Now, after Q3, you will get some results set. Then you can go to Q4 and then result, then this, then in last, you will have the final result set, right? Something like that. So this is a kind of, a non-uniform, so-called systematic, but it is a directional task. I mean, this search is entirely, because it is a process, it is having some velocity, it is having some displacement. So basically, but it is directional, but it is not a uniform or it is not a linear thing, you can see, right? So each and every, this dash line indicates the path of your query propagation or query direction. But each and every drift, each and every curve where you're observing curve or extreme curve indicates the change in thought process. Change in thought process, change in knowledge or knowledge gained during the search process, right? So this is just a depiction of whatever we have discussed in the previous lectures actually. Right, now let's come back again and see and emphasize these two frameworks, because today's lecture is about discussing these two frameworks. It is just the revision what we have discussed in last 10 minutes. It says basically in the case of berry picking, which is talking about which is emphasizing the importance of two basic frameworks. So in the case of berry picking behavior or berry picking phenomena, it naturally depicts the berry search process, whatever it is happening in the real life. In the case of looking for a suitable berry or tasteful berries, or it could be looking for the so-called prepared leaves or tea leaves, something like that, right? So there are other behaviors also existing. I mean, if you observe your daily life, you could find that okay, there are many situations where we are applying different behavior for searching something. Like if you go to library and if you do not refer any document, any detail about the location, you can also find out that okay, because in the library the books are organized in a structured way. They are kept in some based on some scenario, right? So or maybe in the organization. So if the books are stored in an organized way, you can easily find out. Maybe each and every student will have different ways to getting into a specific books, right? So there are many small and large scale behaviors we are also having in our life, daily routine life, because search is something which is fundamental to humans. I mean, it is the first behavior, you can say, and that's what written in the books also, because if you read into the different books which are related to the human evolution in the civilization or in many ways actually, search is something which is coexisting from the very first day, right? So berry picking is one of the behavior which looks like that it could be modern, it could be more systematic, right? So berry picking is basically related to the berry search. Obviously berry search physical behavior. Now it emphasizes on the focused search within the source. This is again repeating and it is revising that what is the motivating factor. So okay, because once you get into a specific food source, once you reaches to particular bush and you pick some berries, now what is the next step? what is the motivation factor in this entire search phenomenon, in this phenomena in situation where we are based on very picky, right? So the in changing information goal needs are motivating factor. So changing information goals needs means it is reflected in the query. So that's what I'm saying. Whatever information we gain, whatever knowledge we gain, that basically is reflected in the change in the needs. It is reflected on the needs updation. Your query is revised, your needs are revised. So that is the motivation factor of a very picking based search phenomena. So you could find, okay, it is possible that you will have a very accurate result, accurate document in the first day, in the first query itself. But after getting into these results, your knowledge is gained, your needs are now changed. So based on this, you will be engaging with the system for the query too, right? So that is this change in information gained, change in knowledge gained, and eventually on due to the updated needs, you are going to engage with system in the subsequent or future query. That is the motivational factor or motivating factor in the case of very picking based system designs. So you can say whatever behaviors we have discussed in the previous class, we have discussed four categories of such behaviors. So where basically query is known to you and some sort of idea about results also you are having, there berry picking is the most suitable. Like for any fact retrieval, any so-called, you can say, where basically it is lookup based kind of situation where query is known to you and result is also known to you, maybe in the partial fashion. Maybe query is known to you partially or result is known to you in full way. So where both factors are query and results, one of it is known, 1001 and 11 kind of thing. On those situations, berry picking is, or berry picking based system is the most suitable approach. But whenever we have the result side portion is unknown, maybe in cases like query is partially known, or maybe you can go to the extreme where both hints are not known, like the fourth category, you should be emphasized on foraging based system design, which say foraging based system design and foraging behavior based says you will have a capability to explore, to control, to read, to overview the food sources, overview the PDFs, overview the results, right? So because it emphasizes on the exploratory browsing, right? You are not going inside any of the food source, any of the documents which you have searched for. You are just interested to read out at least once. Like nowadays you will be facing the same situation because you have started working upon your project work, and if you are new to a domain, you are going to the Google search system or maybe any search system which provides you the list of research papers on a certain domain. So after firing a specific query like machine learning or maybe distributed computing or maybe it could be like recommended system, it could be image processing, anything. After firing to an initial query, you will read it to the title level details of the retrieved search results, retrieved scientific or research papers. After reading to the titles, I mean, if you are exploring the titles only, you are primarily performing foraging behaviors. You are simply browsing the food sources, the results. Maybe out of these 20-30 results, you will dig down 3-4. In the second phase, second iteration, you will read into the abstract level, right? You will read into the introduction level. That is called focused. That is called berry picking, right? So basically foraging says you need to read, you need to explore, you need to have a view on the food sources in its utmost detailed level, right? So most of the search system design, I mean, this is it. What we, whatever I have planned for today's discussion. So based on these two broad behaviors only, each and every system where search is integrated are designed. You can take any example. You could take this supply chain based system, e-retail systems, even these scholarly search system. Any platform you take, wherever this search behavior or search process is integrated, it is important, it is existing. These two broad behaviors are provided in some balanced way. In some system, it is providing lot many features to just explore the articles, explore the results. There are some where they are focusing much more about the focus search. They provide title, keywords, abstract in the very first view. I mean, if you are providing title, along with title, if you are providing abstract details, keywords of the paper, it means you are exposing some details which could be helpful for the reader to start the very picking part, start the focused search within the source, right? So this is how we are balancing two behavior. We are balancing two factors, which is called exploitation and exploration. And this is the bottom philosophy for this course. I mean, each and everything about balancing these two factors, right? And this is what is the theme of any modern day or futuristic system, right? That's it for today. Now, if you have any question, though,